Hello viewers, Wagadaruna taking you through the story for A-Level Principal Mathematics. And in this video, we are going to go through the expected response for Senior 5 Math B end of Term 2 for the year 2025 of Mengo Secondary School. So this video is suitable for students in Senior 5 offering Principal Mathematics as part of their combination. So these are the papers we hope to upload, and if you are there and you have the paper you did in your school, I encourage you to inbox me the paper. You can take a picture or you can use Cam Scanner to scan it into a PDF and you send it to my inbox, which is this WhatsApp number. Also, the same number is one used to order for books. So if you're for both A-Level and O-Level. So for A-Level, there are 2 books of Principal Mathematics, Math for 1 and Math for 2. And for A-Level, there are 2 books still of Physics, Paper 1 and Paper 2. Subsidiary Mathematics, it is 1 book. And Physics for Senior 3 and 4, it is Volume 2 of 2. Then there's an item bank combined containing both Math and Physics item banks for O-Level. What you have not included here and is released is Math Volume 1 of 2, which is for Senior 1 and Senior 2 work. So for copies, for any of the copies, contact the author on this contact. So shall I begin with section A. Now here, like I've told you, the format of assessment is not yet clear. So what Mengo did, it had 2 sections. Section A, which is computational evaluation, which is like what we call old curriculum, and then section B was item based. So that's why you're seeing here section A and section B. So whatever a school chooses, it is still okay because we have not yet got an official communication of the mode of assessment. So question 1 says, the table below shows the grades that Alan got in the 6 tests she did of mathematics and physics, which are these ones. By calculating Spearman's rank correlation coefficient, comment about the correlation between the 2 subjects. So we shall come and tabulate the values. So we shall get values of x and also values of y. Then we shall begin ranking. Ranking is better we do it in descending order. And like you know, in this previously, okay, the old curriculum, an A was the highest mark. So we shall get an A. But there are 2 A's. So what we do, we get the average of the would-be position. So this would have taken position 1 and this position 2. But because they're identical, we shall take the average, which is 1.5. So shall come and put here 1.5 in this column. That's why I'm seeing here 1.5 and also here 1.5. Then next is a B, which is now in position 3, so we shall put 3 there. Next is a C, so we shall put 4. Then next is a D, so we shall put 5 here. And lastly an E, so we shall put 6 there. Then ranks of Y here, the highest is an A, so we shall go to rank 1, followed by a B, so it will get rank 2, followed by a C, so it will get rank 3, followed by a D, so it will get rank 4, followed by E, gets rank 5, and lastly F to get rank 6, like that. Then next will be good subtraction. So 3 minus 1, 6 minus 6, 5 minus 5, 1.5 minus 3, 4 minus 4, and 1.5 minus 2, Okay, then the last column is for square of the differences. So 2 squared, 0 squared, 0 squared, negative 1.5 squared, 0 squared, negative 0.5 squared. Then shall add all these ones and get the total, which we shall put here. So now that you know the total, we can quote the formula for Spearman's and then we substitute. Summation of d squared comes from here. N means number of pairs. 1, 2, 3, 4, 5, 6. That's why you're seeing 6 there. Then the answer has to be in decimals. Some of you are funny, you want to write in fraction form, it is not okay. So next now will be the comment. Comment shall need table. So these are the pairs, they are 6. Then we take a line up to Spearman. Spearman, we have this at 5% and this at 1%. So here they would say significant if the magnitude of the calculated value exceeds the table value. So our calculated value was 0. Okay, magnitude is 0.8143. 0.8143. So you realize that this value is smaller than this. So we shall say not significant at 5%. Also, this value is smaller than this. So we shall still say not significant at 1%. So any of the two comments is okay. So we shall come and conclude on right not significant at 5%, or you can say not significant at 1%. Or you can also write and say there is no significant correlation between math and physics at 5% level of significance, and is okay. That was question 1. Then question 2 says a bus and a taxi are traveling with velocities this and this. Find the possible values of A if the vehicles have the same speed. So speed means magnitude of velocity. So when they say they have the same speed, it means that they have the same magnitude. So I'll come and say for same speed, magnitude of the first velocity is equal to magnitude of the second velocity. So how do we get magnitude of this, which is this one, magnitude of this, which is this one, and equate the two. Then now we have one unknown and we can make it the subject. So you're going to realize that when you put square both sides, this square goes away, even this one goes away, we remain with this. Then rearrange shall come up with a quadratic in A. So that quadratic can be solved using the quadratic formula to come up with the two values of A. And that's what they wanted. That was question 2. Then question 3 says, 2 types of emails, A and B, are sent to customers. Find the probability that a customer never received email B is 7/15. So probability of never received the same as probability of B complement. Then the probability that a customer received none of these emails. None of these emails means neither A nor B, which is 3/10. Then received only one of these emails. Only one, you can write in 2 ways. One can be this. This means B only or A only. That is okay. Another one can choose to say, let me write and say A union B minus A intersection B is still okay. So whatever you prefer to use, it is still okay. Then they said, find the probability that a customer received both emails, and also the probability that a customer received email A. So both emails means they want the probability of A intersection B. Here, email A means the probability of A, like that. So this question It depends on what you prefer. One can say, let me use set theory. Another can say, let me use contingency table. So we shall look at both options. If I choose set theory, I'll come out to draw a Venn diagram, put probability. This one means total probability. PS means sample space, so probability is always 1. Then here, neither of the two, we put it outside the union. Then here, we don't know what to put, so we shall put now unknowns. When you put those unknowns, you realize that the whole of this gives you probability of A, and this one gives you probability of B. So I can come and say that A is X plus Y, and B is Y plus Z. So probability that never received email B. That means that anything apart from this never received email B. So it will be this plus this being equal to that. So there I realize that we have an unknown and it can be got. Okay. So I've got X. The next probability of only one email. Only one means this plus this. So these two, when I add them, I must get that. So I can say that X plus Z is equal to 11 over 30. The good thing, I know the value of X. So put it there, then make Z the subject. Okay. Remember in the question, they want us to get the value of Y. So I come and say that since total probability is 1, I'll add everything and equate to 1. So everything gives you this. There will be one unknown after substituting for X and for Z. So Y will be equal to 1 over 3. That means that the probability of A intersection B is 1 over 3. And that was Roman 1. Then Roman 2, they wanted probability of A. So when you go back to our Venn diagram, probability of A is X plus Y. So now I know X and I know Y. So I'll just come and substitute for X and Y to get the value they want. So that is if you are using a Venn diagram or set theory. What if you are using contingency table? What do you do? So you'll come and say probability of B complement is this. I think we saw that. That means the probability of B is 1 minus its complement to give you 8 over 15. Okay. Then also, probability that of receiving none of the emails is neither A nor B is 3 over 10. From De Morgan's law, when the complement goes outside the bracket to become this, even this sign should change. If it was intersection, it becomes union. Okay? So come as that, therefore union will be 1 minus its complement, which is equal to 7 over 10. But I know the X that this one, they said, received only one of the emails. Let's see what they talked about 11 over 30. They said received only one of the emails. So only one of the emails, like I've told you, it is the same as union minus intersection. Because when you look at this, if I get union means the whole of this. Remove the intersection, you remain with X and Y. So it's the same as only one. That means I can come back here and substitute because now I know the intersection. I don't know the intersection yet. Okay, but I know the union. So when I know the union, I can get the intersection. So make A intersection be the subject. You'll come up with this, which is same as in the previous method. Roman 2, I'll expand the union and then substitute. A union B is that, B is this, intersection is that. So I'm left with PA as the only unknown. So make it the subject and that will be the answer. I think you realize it is the same as before. Question 4 says, in an attempt to determine the height of a building, Dibia throws a stone vertically upwards with a speed of this from the top of the building, and it takes 6 seconds to reach the ground. Find Roman 1, the height of the building, then Roman 2, the time taken to reach the maximum height. So that means that if I'm here, this is the building, I'm at the top, I throw, it goes and back to the ground. So if this is the height, it means that for it to move from A through B to C, displacement will be equal to the height of the building. So there, my work is to use the second equation of motion and substitute to get the value of S. It is negative because the stone is now below the point of projection. So my work is to say that height is scalar. So let me get the magnitude, and that is it. Then Roman 2, the time taken to reach the maximum height. So there we shall use the first equation of motion, and we know that at maximum height, the u is 0, v is 0. U was given as 25 here. G is known, 9.8. Now this is what they want. So when you substitute, we shall be able to get the value of t, and that's what they wanted. Then question 5. Question 5 says, a student has two alternative routes M and N to reach school. The probability that he passes through M is 0.6 and that he passes through N is 0.4. The probability that he arrives to school late, given, you see that word? Given. The probability that he arrives at school late, given that he passed via route M, is 0.16, and the corresponding probability that he passed via route N, and the corresponding probability if he passed via route N is this. So the condition is still there. Find the probability that he arrived to school late. And Roman 2, he passed via route N, given that he never arrived late to school. So questions with conditions are easily done using a tree diagram. So in other words, questions of dependent events are easily done using a tree diagram. So shall come and draw our tree diagram, M, then N, then let given M, not let given M, like that. So shall come and put the probabilities. Passing via M is this, passing via N is this. When I pass via M, probability that I'm late is this, so 1 minus 0.16 is what you put here. When I pass via N, the probability that I'm late is 0.06, so 1 minus 0.06 is 0.94. Okay. Then Roman 1, they asked for Roman 1, they said, find the probability that he arrived to school late. So late, there is this option and also this option, which will be equal to 0.6 times 0.16. The another option is this, which is 0.4 times 0.06, like that. So you come and write both options, then you add them to get the final probability they want. Then Roman 2 is saying we'll find the probability that he passed via route N, given, so N, given that he never arrived late, so L complement, like that. So that would be the probability they want. So I'll come and say n given L complement, numerator is the intersection, denominator is what comes after the slash. So n L complement is this times this. Then L complement is the remainder from this. So we'll come up with 47 over 110. And that's what they wanted. Then question 6 says 3 forces of magnitude this, this, and this, acting in the directions this, this, and this respectively, cause a body to move in the direction this with an effective force of 10 Newton. Find the values of P and theta. So individual forces, we have 12 Newton in the direction south, 30 degrees east. So from south, you move towards east 30 degrees. East is this side. East 30 degrees, then you can locate force 12. Then this one is in due west. So due west will be this. Then P is north, move towards east 30 degrees, like that. So that's what they wanted. But remember, forces are drawn with a ruler. So there's the first one, 30 degrees south, 30 degrees east. Second one is due west. And third one is north, 30 degrees east. Then for the resultant force, they said it is north, 30 degrees east. And that resultant force is 10 Newton. So I'll come and draw it. Okay. Now, when you get the result, when you sum up all these forces, they must be equal to this. That's what the equation means. That means that I'm going to equate. So resolving this in vector form gives you this. Resolving this, it is entirely horizontal, and moving to the left, it gives you this. This one, it has a component of this. Then resolving this, it is now this. There's an equal sign here. So equating vectors means you equate I components alone and also j components alone. And I components are the horizontal components. So equating horizontal components, you'll come up with that, simplify. Then equating vertical components, we shall come up with that, and then we simplify. Those are 2 equations and 2 unknowns, meaning we have to solve simultaneously. So equation 1 divided by equation 2, we shall come up with that. Then you realize that P can cancel and also 11 can cancel to remain with 1 over root 3. And this sign of a cos will become tan. Then using a calculator, the value of theta will be 30. And after knowing theta, I can use either equation 1 or equation 2 to get the value of P. So using equation 1, substitute theta to come up with the value of P as 22. And that's what they wanted. Then question 7 says the mean and standard deviation of the monthly salaries of the employees of a certain company are shillings this and this. If each one's salary is increased by 30%, that's a percentage increase, plus a basic pay of shillings 150,000, determine the new mean and new standard deviation. So one shall select X be and Y be the old and new salary. So X means old, denotes a old salary, and Y means the new salary. So the new salary was increased by 30%, and also there's an additional amount of 150,000. So that simplifies to that. Okay, now if I want to get mean, I'll put bars on both sides. So mean, this one means mean of y will be equal to 1.3 mean of x plus 150, which gives you, substitute, because we know the mean of x is 400, then you can be able to get the new mean. For variance, if this is y, so if y is equal to this, then variance of y will be equal to 1.3 squared times variance of x. Now in variance, we don't mind the constant. We don't mind the constant. We only mind the coefficient of x. I don't know. It's a rule. It's a full rule which can be proved. I think in your school the teacher has proved it. But because they want standard deviation, we shall put square root on both sides. Then we shall come up with standard deviation of y being equal to 1.3 times standard deviation of x. And standard deviation of x was given 10,000. So that would be now the new standard deviation. And that's what they wanted. Question 8 says Sally walks for 3.5 hours at a constant speed of this due west from town A to town B, then walks 1.5 hours at a constant speed of 32 kilometers per hour due north to town C. What is the magnitude of his average velocity for the entire journey A to C? So remember, velocity is a vector quantity. If they had said average speed, it would be different from average velocity. So average speed, velocity will mind the direction. So distance from A to B is this speed times time. Give you this. Then distance from B to C, it is the same thing, speed times time, to give you the distance. Then I can now come and draw, because we're interested in the direction also. So from A to B, I move due west. Then from B to C, I move due north. Then the resultant is from A to C, which can be got by Pythagoras theory. So average velocity in this case, it is A to C over the time taken. So A to C is the magnitude of this squared plus this squared from Pythagoras theory over the time, because for this it was 3.5 and for this it was 1.5. So you come up with 10 kilometers per hour as the magnitude of the average velocity. So that was section A, which is a computational evaluation. Now we shall go to section B, which is application, or what we call scenario based. So part A was about statistics, and item 1 says traffic officers measured the speeds of 60 vehicles on the road where speed limit is at least this, but not exceeding this. So they expect a speed of minimum of this and a maximum of this, like that. The speed limit data was grouped as shown in the table below. Okay. Then here they said, help the officers to, part A, calculate the average speed and also the most frequent speed on the road. Then part B, draw a suitable graph and use it to determine the percentage of drivers who comply with the speed limit. And also find the number of drivers who are too fast. That is, those are beyond the speed limit. So here, because this is group data, the first thing we shall do is to tabulate. So when I tabulate, I come up with, so here, because there were inequalities, what you do, you remove the inequalities, and what you get will be the class, and also it will also be the class boundary. The number of vehicles is our frequency. Then we shall need to get the total of this to give you this. After that, we shall now get the value of x, which is the mid-mark. X is got by saying this plus this divided by 2. So 20 plus 30 divided by 2, 30 plus 35 divided by 2, 35 plus 45 divided by 2, 45 plus 55 divided by 2, 55 plus 60 divided by 2, 60 plus 75 divided by 2, and 75 plus 80 divided by 2. Okay, because they ask for the mean, you shall need to get a column of fx. So this times this gives you 250, 6 times 32.5, 195, 4 times 40, 160, 13 times 50, 650, 8 times 57.5, it is 640, 12 times 67.5, 810, 7 times 77.5, 542.5. Then shall need to get the total of all this to give you 3067.5. Then C, class width. We are getting class width because they ask for mod, or most frequent speed. So class width will go from class boundary. So this 30 minus 20 is 10, 35 minus 30 is 5, 45 minus 35 is 10, 55 minus 45 is 10, 60 minus 55 is 5, 75 minus 60 is 15, 80 minus 75 is 5. So now that we know the values of C and the values of F, we can get the frequency density, which is frequency divided by class width. So 10 divided by 10 is 1, 6 divided by 5 is 1.2, 4 divided by 10 is 0.4, 13 divided by 10 is 1.3, 8 divided by 5 is 1.6, 12 divided by 15 is 0.8, 7 divided by 5 is 1.4. Then from there we shall get the class cumulative frequency for us, so we are able to draw the ogive. So 10 is what we first write, then 10 plus 6 is 16, 16 plus 4, 20, 20 plus 13, 33, 33 plus 8, 41, 41 plus 12, 53, 53 plus 7, 60. So now that we are done with tabulating, we can now answer the questions. The first one was about the mean or average speed, which is summation fx over summation of f. Substitute and get the answer. Next was the mode. Mode, we need to get the difference between the modal frequency and the pre-modal frequency. Also, difference between the modal frequency and the post-modal frequency. So let's see where they were got from. If you look at this column, so each time the class widths are unequal, we now use frequency density column. The highest is this. Okay, so delta 1 means difference between this and the pre-model. Delta 2 means difference between this and the post-model, like that. Then this will be the lower class boundary, and the class width is 5. So now that we know delta 1 and delta 2, we can code the formula correctly, then substitute in the formula to get the output which is the question what they wanted. Then part B said by draw a suitable graph and use it to determine the percentage of drivers who comply with the speed limits. Remember, the speed limits were at least this, but don't exceed this. So from this to 70, how many drivers are there? That's what they want us to obtain in percentage form. And also the number of drivers who are too fast, those who have exceeded the maximum speed limit. So they shall need a graph paper. Then on the graph paper, remember these are the values we hope to tabulate. So we shall draw the horizontal scale, get a horizontal axis and also vertical axis, get a scale for the horizontal using intervals of 2 centimeters. And you label. Do the same for the vertical axis. Using intervals of 2 centimeters, get a good scale and label the vertical axis. Then we shall need a title for the graph you're drawing, a graph of cumulative number of vehicles against their speed. Then we can now plot. We are plotting this and this. So 30 corresponds. That means that 30 on the horizontal will correspond with 10 on the vertical to give you this. 35 on the horizontal will correspond to 16 on the vertical to give you this. 45 on the horizontal will correspond with 20 on the vertical to give you that. 55 on the horizontal will correspond to 33 on the vertical. 60 on the horizontal will correspond to 41 on the vertical. 75 on the horizontal will correspond to 53 on the vertical. And lastly, 80 on the horizontal will correspond to 60 on the vertical. Then we shall draw a smooth curve passing through but also meeting the lower class boundary at 0. So always the starting point here should be 0, and yet it's advisable we use the lower class boundary. If you use the value before the lower class boundary, for example, if you began with 10, then 20, like that, 30, then the 0 here should correspond to 20, which is the lower class boundary. Then you can now come and get a smooth curve, and you can use it to now estimate. So for Roman 1, 47, you shall come and get 47 here on the horizontal, take a vertical line up to meet the curve, then take a horizontal line to meet the vertical axis, and you read off that value, which is 22. Then also go to 70, take it up to meet the curve, then take a horizontal line and read off that value. Then now number of drivers, number of vehicles moving with the speed limit within the speed limit is this minus this. So you come and say the required percentage is those moving within the speed limit over the total number of vehicles times 100% to give you that as the answer. Then those who are too fast are those who are above this, and those are from here up to here, which is 60 minus 50 to give you 10 vehicles. So that was question 1. Then item 1. Now item 2 is about scatter graphs and correlation. The table below shows the data collected by a concerned citizen in a certain area about the number of vehicles X bought in the area, and the number of accidents, Y. The citizen wishes to determine the correlation between X and Y using candles. Remember, candles was not on syllabus before, but now it was added. Then 2, estimate some unknown values using a suitable graph. So task, by calculating candle's correlation coefficient, state the nature of the correlation between X and Y. Then part B, using a suitable graph, determine X when Y is equal to 25 and determine Y when X is equal to 55. So we shall begin by tabulating. So we come and draw a table of what we want. Here we shall need columns of X, Y, then pairs in agreement, pairs in disagreement, and ties in X. Because if you look at the data, there were some values in the X row which were identical. If you look at this 8 and this 8, means there's a tie in X. Also, if you look at this 65 and 65, there was a tie in X. But if you look at these ones, there is nothing like a tie of similar values. If there was a similar value, some ties in Y, it means that even in our column here, in our tabulation, we would have added another column here having what? Having TY, like that. Okay, so now we are going to, in candles, unlike in spearmans, it is okay to rank or not to rank. It is okay to rank or not to rank. It is okay to rearrange or not to rearrange. Though for me, I prefer that we rearrange. We are going to see how easier it can be when someone rearranges. So what do we mean by rearranging? It means that when you have your values like that, first of all, look for the ones which are identical. They are those ones. Then when you are arranging, you arrange in such a way that identical values in X, you arrange that in such a way that the corresponding values of Y for identical values of X are in ascending order. That is why you saw me here. Do you see this 65 here? Let me now. Okay, that's 65 and this 65. Okay, I gave this one, I'm going to write this as, this one is in position 5 and this is position 6. Why are they the same? It is because here, this and this, if I'm to arrange in ascending order, I must begin with this 30, followed by this 35, 32. That is why you're seeing this in position 5 and this in position 6. It is not like in Spearman. So what I want you to get me correctly is that I'm not ranking, I'm rearranging. Because some of you were taught a method, for example, in Mengo says they taught you a method that you first rank. It is okay. There, when you are ranking, you shouldn't violate the ranking of Spearman, so same values get the same rank. But here I'm just rearranging. I am just rearranging in ascending order. So when I do that, I'm going to now rearrange. So starting with this here, this is followed by 2 is here, followed by 3, followed by 4th, then 5, then 6, 7, 7 is where here, 8, 9, 10, 11, and lastly 12, like that. That is the first column. Second column, you you are now going to write corresponding y values for each value of x. One was 35 was corresponding to 41, so I should write 41. Then 45 corresponds with 43, so I should write 43. Then 3 is 50 was corresponding to 38, so I should write 38. That is 3. 4 is 60 was corresponding to 35, so I write 35. Then 5 is 65 corresponding to 30, so I write 30. 6 is 65 still corresponding to 32, so I write 32. 7 is 70 corresponding to 29, so I write 29. 8 is 75 corresponding to 28, so I write 28. 9 is 80 corresponding to 21, so I write 21. And 10 is 80 corresponding to 31, so I write 31. 11 is 85 corresponding to 26, so I write 26. 12 is 90 corresponding to 22, so I write 22, like that. So what I've done, I've rearranged. Quote me well, I have rearranged. I'm saying that because there's a method whereby you have to rank. Now for me, I've chosen a method whereby you have to rearrange in ascending order. Okay, now the part of this is done. I can remove it. And then now go to NC. NC means you list down the pairs in agreement. Now, they are called concordant pairs. How do we know that a pair is in agreement? If I have maybe 35 and 41, and the value below it is 45 and 43, I will say this one is in agreement. That one is in agreement. Reason, from here to here, it is bigger. From here to here, it is still bigger. So it is in agreement. If I had 35 and 41, then I also have here maybe 37 and 40. Here I will say it is in disagreement. Why am I saying that? Because for agreement, both must be above. Now here, from 35 to 37, 37 is above 35. It is okay. But when you look at 41, 40 is below 41. So that is called disagreement. Okay. Then let's look at another option. If I have 35 and 41, then I have 35 and 50. Now that one is a funny thing. Do you know why? It neither agrees nor disagrees. So what do we do? That means that why doesn't it disagree? Of course, from here to here it is bigger, but here it is a tie in X. So what you do, you don't put it under the column of agreement, and also don't put it under the column of disagreement. We put it under the column of ties. Tie in X, so you shall put it in a column of X. If it was like this, 35, 41, then 37, 41. Here it is increasing, okay? But here there is a tie in Y. So you count that under the column of tie in Y. That's why I told you that we didn't include the column of TY because it would be left blank. So it will be left blank since there was no tie in these values. If there was a tie in any of these values, we would have added a column of TY. Now that being understood, we can proceed. So how do we fill these values? This is how you fill. If I want to get what to put here and here, I could use this as the base and I compare it with all the values below it. Mhm. After that, after knowing that, what do you do? All values below, all values below here, all these values, I'm going to count how many are above 41. That's what I write here in number of pairs in agreement. And how many are smaller than 41? So the word above, I think, disturbed you. Let me use the word bigger than. How many in this, how many are greater than 41? That's what I put here. And how many are less than 41? That is what I'll put here, like that. So that means that when I write, now when I come, I realize that when I'm using 41 as the base, it is only this value which is greater than 41. The rest are below, so I'll count. So here I'll put 1, and here I'll put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So here I'll put 10, like that. Then you go to the next. When I use this as the base, how many of these ones are greater than 43? And how many are smaller than 43? That's what you're interested in. So let me highlight for you the ones which are. So realize that there is none greater than. So in short, what you saw being highlighted yellow, yellow means those which are above, greater than. So if you don't see anything in yellow, it means that none is greater than. That's why you are seeing 0 here. And all the rest are 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That's why you see 10 there. When you go to 38, you realize still there's none greater than 38. So here it will be 0, then here 1, 2, 3, 4, 5, 6, 7, 8, 9. So you should put 9 there. So let's put it. Then when we go to now 35, still there is none. So you shall put 0 here, then 1, 2, 3, 4, 5, 6, 7, 8. So you shall put 8 there. Let's do that. When we go to 30, now here, you remember what I told you? Let me first deal with these two. And I talk what I told you. 65 and 30. Then below it, there is 65 and 32. What do we do about those two pairs? This is bigger, but we cannot say it's in agreement. You know why? Because this side, it is not, it is equal to. So we say there is a tie in X. So when you are counting this one, we are going to put it here under ties in X. Because it is neither in agreement, and we cannot say it is under those which are in agreement. And you can also say it's under those which are in disagreement. So it goes under this part here. Down now that is done. So now what about the rest? The rest I have this one. It is about greater than that. So it is only one. So I put 1 here. Then how many are in disagreement? 1, 2, 3, 4, 5. Then you put 5 there. So in short, we are going to put 1, 5, 1. So let's do that. 1, 5, 1, like that. Then next, when I use that as the base, none is greater. So here it will be 0. Then here 1, 2, 3, 4, 5, 6. So we put 6 here. Let's do that. Then now we shall go to this. When this is the base, this is greater. So we shall put 1 here. Then the rest 1, 2, 3, 4. We shall put 4 there. So let's do that. Then next, when we are on 28, it is this one which is greater still. So we shall put 1 here, then 1, 2, 3. Shall put 3 there. Hope you have now got the logic. Then next, here still there is a tie. So this one will be counted under this here. Then these ones are counted here, they're greater. So here it has to be 0. It has to be 0. So we are going to put 2, 0, 1. Then we go to the next here. All of them are smaller, so here it will be 0 and 2. Then next, smaller, so here it will be 0 and 1. Now for 22, there's nothing below it, so we can leave it as blank. We can leave it blank. Then after that, I think you notice something I didn't talk about here, summation of x. We add these ones because we are going to draw as line of best fit. And remember, line of best fit, we need what we call the mean point. So these summations will help us to get the mean point. But the funny thing I did here, we say summation x, no. It has to be summation of y. So this was a spelling error. You make it summation of y. Then these ones, all these ones, I have to add all of them and get the total as 6. These ones, I add all of them and I also get the total as 58. These ones, I also add them and I get the total as 2. Okay, now that I've got that, I can now quote the formula and substitute, then get the output. So this is the formula for candles when they are ties. Formula for candles when they are ties. So this one, we saw it as 6. This we saw it as 58. So 6, 58, 6, 58. Then tying x, we saw it as 2. And here we saw it as 0. And that, so the comment we get the same way we used to comment in Spearman. So we shall come and say, here, how many pairs were they? They were 12. So 12, we shall come for candles, which is this and this. Here they are saying significant if the calculated value exceeds the table value. The magnitude, this is what magnitude. So for us, we got 0.8001. This value is bigger than this, so significant at 5%. This one is also bigger than this, so we shall say significant at 1%. So that's why you're seeing those comments. Then part B, said, using a suitable graph, determine the value of x when y is 25 and the value of y when x is 55. Okay, so we shall come, that means we have to plot a scatter graph. We shall first get the mean point, which is that. Then now go ahead and get a graph paper, draw the horizontal axis and the vertical axis. These are the values we are going to plot. Then use intervals of 2 centimeters to get a good scale for the horizontal, encompassing all the values of x. Then also intervals of 2 centimeters to get a scale for the vertical, encompassing all the values. Then shall plot x is 35 and y is 41. X, we shall also need a title, x 35, y is 41. X is 45, y is 43. X is 50, y is 38. X is 60, Y is 35. X is 65, Y is 30. X is 65, Y is 32. X is 70, Y is 29. X is 75, Y is 28. X is 80, Y is 21. X is 80, Y is 31. X is 85, Y is 26. X is 90, Y is 22. So that is called a scatter diagram. But they wanted us to estimate, so we need to draw a line of best fit. To draw a line of best fit, we shall also need the mean point. So when X is 66.75 and Y is 31.33, we shall come up with that as our mean point. So the line of best fit must be drawn with a long ruler and passing through the mean point and any one or two more points, leaving equal or almost equal points on either side. So here it has passed through the mean point, okay? It has passed through 1, 2, 3 other points. What about points left on this side? There is 1, 2, 3, 4. Then this side, 1, 2, 3, 4. So there it is, we can say it is a good line of best fit. Then we shall now estimate. They told us when Y is 25, what is X? So drop to meet the horizontal axis and read off that value. Then also, so we shall come here and say when Y is 25, X is 82.5. Then Roman 2, when X is 55, Y will be rid of that value, 36. So we shall come and say when X is 55, Y is 36. And that's what they wanted. We shall go to item 3. Item 3 says, a study was conducted to examine two independent preventive actions, A and B, independent, so meaning that A and B are independent events. Event A is a person is vaccinated against a new virus, and event B is a person wears a mask regularly. The probability that a person is both vaccinated and wears a mask is twice the probability that a person is only vaccinated. The probability that a person is either vaccinated or wears a mask is 71 over 75. Task A. Explain to someone who does not understand probability symbols the meaning of P of A complement intersection B complement. Then Roman 2, P of A intersection B complement. So A complement intersection B complement means neither nor. So you shall come and say denotes the probability that a person is neither vaccinated against the new virus nor wears a mask. Then this one means denotes that a person is only vaccinated against a new virus, because this one means A only, and A is about being vaccinated against a new virus. Or can tell us what each means. So this one you can say just the person is vaccinated against a new virus and to mean intersection and does not wear a mask regularly. Then part B, they told us prove that their complements are also independent. So it is known that the A and B are independent. Now they want us to prove that even their complements are independent. So for events A complement and B complement to be independent, it means that their intersection is equal to the product of individual events. So in short, this is what they want us to prove, that this is equal to this. The best is to begin from the left-hand side. Then use De Morgan's law to come up with this. I think we already saw that earlier on. Then that one is the same as 1 minus the union. Expand the union because it is known. This one is the same as product of A plus product of B minus A intersection B. Now for this one, it is already known they are independent. So I can replace them with this. Then I can open brackets. When I open bracket, this becomes minus, this and this becomes minus, this and this makes it plus. Then I'll pair this alone and these two alone. So this alone gives you this, and these ones, probability of B is common, so minus probability of B. When I pull out negative probability of B, here I remain with positive one, and here I remain with negative P of A. That's why you see minus. Then 1 minus probability of A is A complement, even here A complement. So now I have A complement, which is common. So pull it out. Come up with this, and 1 minus B is B complement. And that is what they wanted. Then part C says, by determining the individual probabilities of A and of B, state with a reason which action is most likely taken by the people of the area. So they want you to get probability of A alone and also probability of A and probability of B and find out which is greater. The one which is greater is the one which is most likely taken action. So there it is okay to use laws or contingent stable or set theory. So when I use set, total probability is always 1. Then if this is x, this will be 2x. It comes from the other condition. Let us first go back and we see. The condition said the probability that a person is both vaccinated and wears a mask, that is now probability of A intersection B, is twice the probability that a person is only vaccinated A only. So probability of A intersection B is equal to twice probability of A only. That means that if probability of A only is X, then this one will be 2x. That's why we put there 2x here. We put here 2x on the intersection. Then here I put any other unknown. So that means that probability of A is the sum of these two, and also probability of B is the sum of these two, like that. Okay. So there is some condition they give us also, which was 71 over 75. Let me first read and I see. It said the probability that a person is either vaccinated or wears a mask is this 71 over 75. O means union. So probability of A union B is 71 over 75. So that will mean that in my Venn diagram here, this plus this plus this plus this should be equal to 71 over 75. So now we are going to begin by saying that since the two events A and B are independent, it means that the Intersection is the product of individual probabilities. Intersection is this. Then the product, we have PA and also PB. So if I want to get PA, if I want to get PB, I'll substitute for intersection and PA to remain with PB as the unknown. So here I realize that X will cancel and you remain with probability of B as 2/3. Now I've got probability of B. I can also say the whole of this is probability of B. Then if I add on this, I can get this 71/75. Yeah, so probability of B, which is 2/3. So 2/3 plus X should give me 71/75. In this case, I'll get X as 7/25. So I've got 7/25. Here it will be 14/25. I don't know why yet, so I'll come and say that from probability of B. Okay, let me first get probability of A. Probability of A will now be 21/25. So I think that we have answered the part they wanted, because they wanted you to get individual probabilities, PA and PB. So since PA is greater than PE, it means that more people are vaccinated against the new virus than those who wear masks regularly. So that was part C. Then part D. Part D says, what percentage of people take only one of the preventive actions? Only one. So only one means A only plus B only. So they want this plus this, but we don't know why yet. The good thing, we now know that this one is equal to probability of B, where is it? 2/3. And I know that X is 7/25. That means I can get the value of Y. So I'll come here and say the probability of B is that, substitute for X, you'll be able to get the value of Y. Then I can get the probability of A only 1, which is that. Then percentage, it will be multiplied by 100. So from probability to percentage, you simply multiply by 100. That was item 3. Now we shall go to item 4. Item 4 says, Lake Tech Company Limited deals in computers and their major parts, namely the CPU, which is C, the monitor, which is M, and the keyboard, denoted by K. Experience has it that the probability that C works correctly is this. The probability that M works correctly is 0.95. And the probability that K works correctly is 0.97. Given that P3 is the probability that all the three parts work correctly, P2, probability that only 2 of them work correctly, and P0, probability that none of them work correctly, the procurement manager of the company will make a new order if P3 is less or equal to 0.9, or P2 is less or equal to 0.09, or P0 is greater than 0.1. To maintain the quality of the employees, the employees regularly answer questions which are randomly and automatically generated by the computer. The probability that first question is answered correctly is 0.75. If a question is answered correctly, the probability of answering the next question correctly reduces by 0.05. So that is a condition. And like I've told you, each time you see a condition or each time you see dependent events, it is better you use a tree diagram. But if the question is answered wrongly, the probabilities of answering the next question remain unchanged. Task: by determining probabilities P3, P2, and P0, state whether or not the manager should make a new order of the computer parts. So let's first get that. So like I've told you, we shall need a tree diagram. So PC is that, P and C complement is that, PM is that, and M complement is that, and PK is that, and PK complement is that. So for these ones, they are independent. CPU, monitor, keyboard, their operations are independent. So we shall take them as independent events. So P3 means all work. CMK are working. CMK, to give you that. So this value is greater than 0.9. Let's also go to P2, only 2. So only 2, it means that K is faulty and these are working. M is faulty, these two are working. This is faulty, these two are working. So substitute independent events. Then you shall get the answer. When we compare, P2 is greater than 0.09. Okay. Then what about this? P0, none works. So all are complements. Shall come up with that, and is still less than 0.1. So since P3 is greater than this is this, and this is this, then the manager should not make a new order. That was part A. Now shall go to part B. Part B, they said by determining the probability that second question is answered correctly, and the probability that the third question is answered correctly. Explain to the manager which of the questions, first, second, or third, is most likely given a correct response to. So we need to see which has the highest probability of the three. Remember, they told us that if the previous question was correct, then the next question the probability will reduce by 0.505. Okay. So you first draw a tree diagram. C means correct and C complement means not correct. So the first one, 0.75, and the excess to make one is 0.25. Because this is correct here, this one should reduce. So to reduce to give you 0.7, here excess 1 minus 0.7 gives you 0.3. Here, because this was wrong, the probability maintained 0.75. Here it will be 0.25. Then here, because this was correct, here it should reduce to give you 0.65. And here 1 minus 0.65 is 0.35. Here, because this is wrong, it will remain as this, which is 0.7, and here 0.3. Because this is correct, it means that here it will reduce to 0.7 and here 0.3. Because this is wrong, it will remain as this, which is 0.75 and here 0.25. So probably the second is correct is C2, which is that. Then probability that third is correct is C3. So all the options which end with 63 are needed. Then you come up with that from the tree diagram. So C1 is this, C2 is this, and C3 is this. So you realize that this is highest. So the first question was answered most since it has the highest probability. Then we shall go to item 5. Item 5 says, a traffic police officer is monitoring a highway when an overloaded taxi traveling at 90 kilometers per hour passes him at point A. 2 seconds later, the officer starts his car from rest and begins to chase, accelerating uniformly at this, until the police car catches up with the taxi at B. After meeting at B, the officer suddenly applies brakes and decelerates uniformly at 12 meters per second until it comes to rest at C. While the taxi keeps going at the same speed for 3 more seconds and then applies the brakes and decelerates uniformly for a further 6 seconds before coming to rest. For record purposes, just in case there is need to invoke the law, the officer needs to take record of all the necessary information. So task, help the officer to provide the following. 1. How long does it take the police car to travel from A to B? Determine the distance AB. At what speed was the police car traveling when it just reached B? How long does the police car take to travel from B to C, and at what rate did the taxi decelerate before coming to rest? Okay, so here we shall say let T be the time taken by the police car from A to B. So for motion AB of the police car, using the second equation of motion, we shall substitute. Here it began from rest, that's why it is 0, accelerated at 6 meters per second squared, and took time capital T. So that gives us equation 1. Then for motion still AB of the taxi, for it was moving at a constant speed, so acceleration is 0. But the time taken was 2 seconds more. Initial speed was this. So we shall come up with that as SAB. Because they are all SAB, I can substitute this here. We come up with that, which is a quadratic in T, meaning I can solve it using quadratic formula to get the two values of T. And I'll ignore this negative and take the positive one. So that means we've answered the first question, which is how long. How long is in terms of time. Then the distance, they want the SAB. I can use any of the two equations to get the distance, which is 300 meters. Then part C, they asked for at what speed was the police car traveling when it just reached at B? So velocity of the police car at B. For motion AB of the police car, using first equation of motion, U is 0, A is 6, and time of sprint as 10, so we get 60 as the velocity of the police car. Then part D, how long does the police car take to travel from B to C? Remember, here they told us something. After meeting B, the officer suddenly applies brakes and decelerates uniformly at 12 meters per second squared until it comes to rest at C. So there is a deceleration now. So we shall come and say for motion BC of the police car, first equation of motion, substitute V should be 0, use 60, A should be now negative 12 to give you T as 5. The police car took 5 seconds to travel from B to C. Then part E. Part E says, at what rate did the taxi decelerate before coming to rest? So remember here they told us that while the taxi keeps on going at the same speed for 3 more minutes and then applies brakes. And decelerates uniformly for a further 6 seconds before coming to rest. Okay. So for motion BC of the taxi, V is the first equation of motion, V is that, U is that, and is that. So that will be the deceleration. So the taxi decelerated at a rate of this before coming to rest, and that's what they wanted. Then item 6 says, an engineer is designing a steel rectangular gate ABCD for a drawbridge system. The frame has dimensions AB as 4 meters and BC as 3 meters. Various mechanical forces may have different sources of magnitude. This act along these sides respectively in the directions given by the order of the letters. Take AB and AD as the reference axis. Task: by writing each of the forces into vector form, help the engineer to determine the magnitude of one single effective force acting on the frame and the direction in which the frame will move if nothing is done to stop it. So we shall need to draw the forces rectangle ABCD, ensuring that AB is horizontal and AD is vertical. So we shall put the forces. AB it was 9, BC it was 3, CD was 8, DA was 12, and SC it was 30. So because it's a rectangle, this one is not 45, it's any angle which you don't know, but you can get it by using sides. So sides, we know that AB is 4 and BC is 3, so this is 3 meters. That means that by Pythagorean theory, SC would be 5 meters, so sine beta would be opposite over hypotenuse, cos will be adjacent over hypotenuse, to give you that. Then by writing each force in vector form, 9 is entirely horizontal, so it will be 9, 0. 3 is entirely vertical, so it will be 0, 3. 8 is entirely horizontal, moving towards the negative side, so it will be negative 8, 0. Then force dA is entirely vertical and downwards, so it will be 0, negative 12. And SC is at an angle, so it will be 30 cos beta as the horizontal and 30 sin beta as the vertical. Cos beta is 0.8, sin beta is 0.6, so you come up with 2418 as force of SC. Then now that I've got all the individual forces in vector form, I can get the resultant by addition, which gives me 25 horizontal component and 9 vertical component. The magnitude is got from Pythagoras theory, and then the direction, we shall need positive horizontal and positive vertical to give you the resultant. So I can use SOHCAHTOA to get the value of theta. Opposite over adjacent gives you tan, therefore theta will be 19.8. Then I'll conclude the magnitude of the single force is this, acting in the direction this, above a B. So that brings us to the end of this video. Thank you for watching, and be reminded the next video will be on Math for 1 end of term 2 for Gayaza High School. So if you have not yet subscribed, please click on the subscribe button below this video so that you can receive updates when the next video has been uploaded. Also, if you know any student who is not yet on this platform, please share the link of this video with them via social media platforms like Facebook and WhatsApp so that you can all benefit as a family.